that I forgot to cover in lesson 7 in my previous video was this concept of the perfect square trinomial. And it is really important, so I want to make sure I cover it. This is on page 365 in lesson 7. And the question asks, which of the following are perfect square trinomials? So a perfect square trinomial is a trinomial that factors into twins. So I'm going to factor this and see if it factors into two of the exact same thing. So this is an easy trinomial. I need to think of two numbers that times to 4 add to 4. That'll be 2 and 2. And because these two factors are exactly the same, you could write them like this, but that is optional. And this would be a perfect square trinomial because it factors into two exact factors like this. Okay, now note that if one is a minus, it's no longer twins. So that would not be a perfect square trinomial, but these are exactly the same. So let's try this one. Can I think of two numbers that times to 6 and add to -9? Let's see. So 6 times 1 doesn't really work. Actually, it doesn't even look like this one factors. So if it doesn't factor, there's no way it can be a perfect square trinomial, right? Okay, this one's really interesting. Now, normally I would be checking for a GCF, and there isn't one. And then when there isn't a GCF, I start to panic a little bit because I know I have to do a decomposition. Now, in this case, I am going to try and use a little shortcut. You can use a decomposition to factor this out and see if it works out. But it simply asks if it's a perfect square trinomial. If it was a perfect square trinomial, what that means is that I would have two factors that are exactly the same. So the first one, the first two terms had better times out to 4x squared. So I already know that it better be like this. And the last two terms better times to 81, so it better be like this, like if they were twins. But let's just say that I wasn't sure. So I'm just going to like pretend and see if this actually foils out to the correct thing. So this is 4x squared minus 18x minus 18x plus 81. And actually, look, it does work out that if you factor this into twins, this does come out to the middle term, -36x. So just by trial and error, by seeing if it works out, I can see that this is a perfect square trinomial. You can do a decomposition, and you would get the same thing, but this is just a little bit less work. So let me just try this last one here. So if this was a perfect square trinomial, then in theory, this would be -4. Wait a second. There's no way this can be a perfect square trinomial because to get a -16, you're going to have one be negative and one be positive. So already, if that's the case, they're not twins. So I can already tell that this is not a perfect square trinomial. If you wanted to, you could try and factor it. It doesn't even look like it factors. So there's multiple reasons why that's not a perfect square trinomial. This concept follows through in example 2, where we're looking at, okay, so let's suppose that it was a perfect square trinomial. What does the middle term have to be? So how does this work? Well, let's see. If it was twins, to get 100, I have to make this 10 and this 10. And if you FOIL it out, plus 10x plus 10x, because of these guys, right, plus 100. So if I FOIL this out, I'm realizing that the middle term has to be 20x, right there. Okay, and you can see that over here as well. If I wanted to do a more complicated solution, if this was twins, these two would times to 25, these two would times to 36, and because it's positive, I guess I'll put +1 here. So what I'm interested in, if they were twins, what's the middle term? Well, I'm going to get a term that's 30x here, and I'm going to get another 30x here. So the middle one better be 60x. I'll do one more example. So this one is a bit more complicated because they didn't give us the last term. But if it was twins, the first two had better be like this, times to 9m squared. And then the middle one has to come out to 24. So that means that half of that middle term has to come from these two foiling. And the other half has to come from these two foiling. So to get half of 24, we have to try and get 12 out of here. So 4 times 3, and 12 out of here, 4 times 3. Very tricky situation. Okay, but if you do that correctly, you'll realize that the final term, 4 times 4, must have been 16. So the important thing for you to remember is the definition of a perfect square trinomial. A perfect square trinomial is a trinomial that factors into twin factors.